Somewhere, right now, in a universe governed by the same laws of physics you live in, a version of tomorrow may already exist, not as a prediction, not as a probability, not as something waiting in line to happen, as a place. A location in a structure so vast that your entire life, every breath you've taken, every conversation you'll ever have, the moment you were born and the moment you will die, may already be sitting inside it, fixed, complete, unmoving, not happening, simply existing. This is not a thought experiment from a science fiction writer. This is a serious mainstream conclusion drawn directly from Albert Einstein's own equations. Equations so well tested that they steer spacecraft, correct your GPS, and predicted over a century in advance the exact shape of gravitational waves finally detected in 2015. And those same equations carry an uncomfortable implication that Einstein himself struggled to sit with. The future might already be there, so did you. Let that settle for a moment, because we are about to take it apart, piece by piece, until you understand exactly what physicists mean when they say something so strange it sounds almost impossible to believe. Time may not flow at all. Why this question won't leave you alone. Every human being who has ever lived has trusted one thing without question, that the past is gone, the future is open, and only now is real. You remember yesterday because it happened. You don't remember tomorrow because it hasn't happened yet. That feels like the most obvious fact in the universe. It feels less like a theory and more like the ground you're standing on, but physics has spent over a century quietly chipping away at that ground. Not because physicists enjoy overturning common sense for its own sake, but because when you follow the mathematics of relativity honestly, all the way to its conclusions, the comfortable idea of a single universal now, a moving spotlight illuminating the present moment while everything before it goes dark and everything after it waits in shadow, simply falls apart. Replacing it is something colder, stranger, and far more beautiful, a four-dimensional structure where time is not something that passes, but something that simply is, laid out like the pages of a book that already contains its ending even though you haven't turned to that page yet. This matters because it touches the most personal question there is. If the future already exists, what does that mean for choice, for change, for the sense that your life is something you are actively building, moment by moment, rather than something you are merely walking through? Scientists still argue about the answer. Some of the most brilliant minds of the 20th century landed on completely opposite sides, and the argument is not settled yet. The man who discovered his own discovery was terrifying to understand how physics arrived at this idea. We have to go back to a quiet office in Bern, Switzerland, in 1905, where a 26-year-old patent clerk named Albert Einstein was working through a problem that had been bothering him for years. At the time, physicists believed in something called absolute time, a single universal clock ticking away in the background of the universe, the same for everyone, everywhere. If two events happened at the same moment for you, they happened at the same moment for everyone else too, no matter where they were standing or how fast they were moving. It seemed obvious. It also turned out to be wrong. Einstein realized that the speed of light is the same for every observer, regardless of how fast they themselves are moving. That single fact, when you follow it honestly, destroys the idea of a universal now. Here's the thought experiment that changed everything. Imagine a very long train moving at extremely high speed. And imagine two bolts of lightning strike the front and back of that train at exactly the same instant, according to someone standing still on the platform outside. To that platform observer, the two lightning strikes are simultaneous, same moment, no debate. But imagine a passenger sitting exactly in the middle of the train. Because the train is moving forward, she is rushing toward the light coming from the front strike and moving away from the light coming from the back strike. The light from the front reaches her first. From her perspective, the front lightning bolt struck before the back one. Both observers are correct. Neither is making an error. There is no hidden real answer about which lightning bolt truly struck first because there is no universal moment of now that both of them share. Simultaneity, the very idea of two things happening at the same time, depends entirely on how you are moving through space. This is called the relativity of simultaneity, and it is not a philosophical guess. It has been confirmed experimentally over and over in particle accelerators, in atomic clocks flown around the Earth, in the GPS satellites orbiting above you right now, which must correct for exactly this effect, or your phone's location would drift by miles within a single day. Einstein realized, almost with a kind of dread, that this meant something enormous. If now is different for different observers, then there is no single universal present moment slicing the universe into the past that has happened and the future that hasn't. Instead, every observer carries their own personal slice of now, tilted at a slightly different angle through spacetime, and none of those slices is more correct than any other. The mathematician who saw the shape of time itself. 3 years after Einstein published this idea, his former mathematics professor Hermann Minkowski stood up in front of an audience in Cologne and said something that still gives physicists chills today. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a union of the two will preserve an independent reality. Minkowski had realized that Einstein's relativity wasn't just describing strange effects of motion, it was revealing that space and time are woven into a single four-dimensional fabric. He called it spacetime. Think of it like this. Imagine you only ever experienced 2 dimensions. Imagine you were a character living inside a flat drawing, only able to perceive left, right, and up, down, with no concept of depth. You would think your world was a flat surface, but someone looking at the page from outside would see that the page itself has a shape, a boundary, a structure that exists all at once, all the way to its edges. Minkowski's insight is that our universe works the same way, except with time as an additional direction, alongside the 3 dimensions of space we already know. In this 4-dimensional structure, called a Minkowski diagram, every event that has ever happened or will ever happen has a fixed location. Not a location that appears and then vanishes as it becomes the past. A permanent location, the way a city has a permanent location on a map, regardless of whether you are currently visiting it. This structure is what physicists now call the block universe. In the block universe, time does not flow past you like a river. Instead, your entire life, birth to death, already exists within the block. The way an entire novel already exists on a shelf, even though you are only reading page 143 right now. The character in chapter 1 doesn't experience chapter 40 as not yet real. It's simply not the page they're on. This is what physicists mean by eternalism. Past, present, and future are all equally real, all existing together permanently inside the 4-dimensional structure of spacetime. The sensation of time passing is not a feature of the universe outside your skull. It's something your consciousness generates, page by page, as it moves through a structure that was already complete before you started reading. The proof that shook Einstein's closest friend. If the story ended there, it might already sound reasonable enough to political skeptics as yet another strange relativity effect. But in 1949, something happened that pushed the idea from strange to genuinely disturbing. Kurt Gödel, the brilliant and famously eccentric logician, the same man who had already shattered the foundations of mathematics with his incompleteness theorems, was working at Princeton, walking to and from his office nearly every day with his close friend Albert Einstein. As a gift for Einstein's 70th birthday, Gödel handed him a mathematical proof. He had found an exact solution to Einstein's own field equations, a description of a possible universe entirely consistent with the laws of general relativity, in which a rotating cosmos would allow an observer to travel along a path through spacetime that returned to their own past. A closed time loop. Time travel, permitted by the very equations Einstein himself had written down. Einstein was deeply unsettled. In his later writings, he admitted that Gödel's solution posed a genuine problem for the intuitive idea of time as something that passes. If it is mathematically possible, even in principle, for someone to travel into their own past and meet an earlier version of themselves, then that earlier version of themselves must already be there waiting at that point in space-time for that meeting to occur. The past cannot be gone if it's a place you could, in principle, revisit. We do not live in a rotating Gödel universe. Our own universe does not appear to permit these closed time loops. But the mere mathematical possibility, arising honestly from Einstein's own field equations, was proof that the equations themselves treat all moments of time as equally real, equally existing locations, not as a sequence of moments where only one is lit up as real while the others are extinguished. 2 physicists, Charles Reit-Dijk and Hilary Putnam, later combined Gödel's insight with the relativity of simultaneity into what's now called the Reit-Dijk-Putnam argument. If simultaneity is relative, meaning different observers disagree about which events count as now, and if we accept that everything in someone's now must be real, then by chaining together different observers moving at different speeds, you can show that events in what one observer calls their future must already be real for another observer's now. Follow the logic far enough, and the argument concludes that the entire future must already be as real as the present. Not everyone accepts this argument. We'll get to the disagreement, but it's the reason so many physicists, quietly in their most honest moments, will tell you that eternalism, the frozen block universe view, is where the mathematics actually leads. What it means to exist inside a light cone. To really feel this idea, rather than just hear it, it helps to picture your own life the way physicists do, not as a dot moving through time, but as a long unbroken thread. Physicists call this thread your world line. It's the entire path your body traces through 4-dimensional space-time from the moment and place of your birth to the moment and place of your death. Right now, in this instant, you're not at a point in time. You are, in a much deeper sense, a 4-dimensional shape, a thread stretching from birth to death, and the you reading these words is simply the cross-section of that thread that happens to be conscious at this particular slice. Around every point on your world line exists something called a light cone, the boundary of everything that could possibly influence that point or be influenced by it, given that nothing can travel faster than light. Your past light cone contains every event that could have physically affected you up to this moment. Your future light cone contains every event you could possibly affect from here onward. Here is the unsettling part. Within the block universe, your future light cone isn't an empty, unwritten space waiting to be filled in. It's already a permanent geometric structure sitting inside the block, the same way the shape of a mountain range is a permanent structure on a map, regardless of whether you've hiked it yet. This doesn't mean nothing is undetermined. As we'll see, there's real scientific debate about how quantum uncertainty fits into this picture, but it does mean that the geometry itself, the raw structure of spacetime, treats yesterday and next year with the same mathematical seriousness. Neither is privileged, neither glows brighter than the other. Only your particular position on your world line determines what you happen to call now. The other side of the argument here is where honesty about uncertainty matters most, because not every serious physicist or philosopher accepts eternalism. The opposing view is called presentism, the idea that only the present moment is real. The past has ceased to exist, it exists only as memory and record. The future does not yet exist, it exists only as possibility. Presentists argue that our overwhelming universal experience of time actually flowing, of the present genuinely becoming the past, of the future genuinely becoming open undetermined territory, is too fundamental a feature of reality to dismiss as a mere illusion of consciousness. Philosophers like William Lane Craig have argued that the relativity of simultaneity doesn't actually force eternalism upon us. It only shows that there's no single observed universal now, which is different from saying there's no actual universal now beneath the observations. Some physicists similarly argue for a version called the growing block universe, a middle position where the past and present are real and fixed, but the future genuinely does not exist yet. It is still being added, moment by moment, to the growing edge of the block, like new pages being written into a book that has no ending yet. There are also physicists, including some who study quantum gravity, who argue that time may be even stranger than either picture suggests. That at the deepest level, in theories like loop quantum gravity, time itself might not be a fundamental ingredient of reality at all, but something that emerges from a timeless, more fundamental layer. The way temperature emerges from the collective motion of countless individual molecules, even though no single molecule has a temperature of its own. So the honest state of the field, as of today, is this. The block universe, eternalist view, is the one most naturally suggested by special and general relativity taken at face value, and it is the majority view among physicists who have thought carefully about the subject, but it is not a proven fact. It remains an interpretation, an extremely well-motivated one, but an interpretation nonetheless, and serious credentialed scientists and philosophers continue to defend presentism and the growing block model. What quantum physics adds to the mystery. If relativity alone weren't strange enough, quantum mechanics adds another layer that makes the picture even harder to pin down. In the everyday classical world, we assume causes come before effects. That your decision now can only affect the future, never the past. But some of the strangest experiments in modern physics test whether this is strictly true at the quantum level. Consider the delayed choice quantum eraser, an experiment first proposed by physicist John Archibald Wheeler and later carried out in real laboratories. In simplified terms, the experiment sends individual particles of light, photons, through a setup where a measurement made after a photon has already been detected can seemingly determine whether that photon behaved earlier like a wave or like a particle. It sounds at first glance like it's suggesting that a choice made now can reach backward and change the past. That is not in fact the correct interpretation, and reputable physicists are careful to clarify that these experiments do not allow sending information backward in time and do not violate causality in any way that could be used, for example, to change a past outcome you've already observed. What they do reveal is that the ordinary common-sense picture of first this happens, then that happens, in that order for everyone, breaks down at the quantum scale in ways that are still being investigated. Some physicists interpret these results as further evidence that treating time as a single, universal, one-directional flow oversimplifies something much stranger happening underneath. This remains an area of active research. Retrocausal interpretations of quantum mechanics, models where influences might, in a very constrained and mathematically careful sense, propagate backward in time, exist as legitimate but minority positions in theoretical physics. They are not proven. They are one of several competing ways to make sense of quantum weirdness, alongside more mainstream interpretations like Copenhagen, many worlds, and pilot wave theory. But their mere existence as viable research programs shows how unsettled the true relationship between time and causality remains, even a century after Einstein's original insight. Where Roger Penrose enters the story. Few living physicists have thought as deeply or as unconventionally about the nature of time as Sir Roger Penrose. Penrose is perhaps best known for his work proving, alongside Stephen Hawking, that black holes and the Big Bang itself must contain singularities, points where spacetime and by extension time itself becomes infinitely curved and physics as we know it breaks down. That work alone reshaped our understanding of how time behaves at the most extreme edges of the universe. But Penrose has also proposed something far stranger, a cosmological model called conformal cyclic cosmology, in which the universe does not have one single beginning and one final heat death, but instead passes through an endless sequence of cycles, each aeon beginning with its own Big Bang, and ending in a state so diffuse, so stretched out, so empty of mass, that it becomes mathematically indistinguishable from the beginning of a new cycle. In Penrose's model, the end of time and the beginning of time become, in a precise geometric sense, the same event, viewed from two different scales. This is squarely in the territory of speculative active research, not established science. Penrose himself has pointed to controversial patterns in the cosmic microwave background, the faint afterglow of the Big Bang, which he interprets as possible echoes from a previous aeon. Other cosmologists have examined the same data and found the evidence unconvincing, arguing that the patterns Penrose identifies are consistent with ordinary statistical noise. This is very much an open scientific debate, not a settled conclusion, and it should be understood as one bold minority hypothesis among many competing models of the universe's ultimate fate. What makes Penrose's broader body of work relevant here is his insistence across decades of writing that our intuitive picture of time as something that flows, that has a single universal direction, that treats now as special, is almost certainly an oversimplification of something far more geometric and far stranger, a view he shares from very different angles, with Einstein, Minkowski, and Gödel before him. What this means for free will. This is where the physics stops being merely fascinating and starts becoming personal. If the block universe view is correct, if your future is in some real sense already sitting there in the four-dimensional structure of spacetime as fixed and complete as your past, what does that mean for the choices you feel yourself making every single day? This is one of the oldest questions in philosophy, now dressed in the language of modern physics, and there isn't a single answer that all physicists or philosophers agree on. Some argue that a block universe is simply incompatible with free will in any meaningful sense. If your decision to read this sentence and every decision you will ever make is already a fixed coordinate within the block, then choice, as we ordinarily imagine it, is an illusion generated by a brain that doesn't have access to its own already written future. Others, including many physicists and philosophers who accept eternalism, argue this conclusion moves too fast. They point out that even inside the block universe, your decisions remain the actual physical cause of your future light cone taking the shape that it does. Nothing in the block universe model says your choices don't matter to the outcome. It only says that the entire cause and effect chain, including the moment of your choosing, is laid out as a single four-dimensional structure rather than being written in real time. In this view, called compatibilism, free will isn't about whether the future is fixed. It's about whether your reasoning, your values, and your desires are the actual causal source of your actions. And within the block universe, they still are. They're simply woven permanently into the fabric alongside everything else. There is no scientific consensus that resolves this. It remains quite genuinely one of the great open questions where physics and philosophy meet, and reasonable, deeply informed people land on very different sides of it. Modern evidence, modern tools. None of this remains purely theoretical. Every year, the tools available to test the predictions of relativity, the same equations that give rise to the block universe picture, grow more precise. The 2015 detection of gravitational waves by LIGO confirmed, with extraordinary precision, that spacetime itself ripples and bends exactly as Einstein's equations predicted a century earlier. Direct evidence that space and time really do behave as a single unified physical structure, not merely a convenient mathematical bookkeeping device. Atomic clocks, now precise enough to detect time dilation across a difference in height of just a single foot near Earth's surface, continue to confirm that time genuinely runs at different rates for different observers, depending on their velocity and the strength of gravity around them. Direct everyday evidence of exactly the relativity of simultaneity that first led Einstein toward the block universe conclusion. The Event Horizon Telescope's images of black holes and ongoing observations from the James Webb Space Telescope peering back toward the earliest galaxies in the universe's history continue to test general relativity in more extreme environments than ever before, and so far, the theory that gives rise to the block universe interpretation has passed every single test thrown at it. None of these experiments directly prove that the future already exists in a metaphysical sense that remains and may always remain a question that sits at the boundary between physics and philosophy. But every one of these experiments confirms with growing precision the strange relativistic foundation upon which the entire idea rests. What it means to live inside the block, step back from the equations for a moment, and consider what it might feel like if this picture is true. It would mean that somewhere within the structure of spacetime, the day you were born is not gone. It is simply a location you are no longer occupying, the way your childhood home still exists on the map, even though you no longer live there. It would mean that the version of you reading this sentence right now, and the version of you who will finish reading it 30 seconds from now, and the version of you who will one day take your final breath are not separate, sequential events happening to a single traveling you. They are all simultaneously permanent threads within a single four-dimensional shape, a shape that has always existed in its entirety, the way a sculpture exists in its entirety, even though you can only see one side of it at a time. It would mean that grief and joy and every ordinary Tuesday afternoon you've ever lived through are not fading into non-existence as the years pass. They are simply becoming further away along your world line. Still there, still real, still exactly as true as they ever were, just no longer the page you happen to be reading. And it would mean that the future, however uncertain it feels from where you're standing, is not empty, it is not blank, it is not waiting to be filled in by your choices in the way a canvas waits for paint. It is already a landscape. You simply haven't arrived yet. The question that remains here is what no equation, no experiment, and no physicist has yet been able to answer. If the future is truly already there, fixed within the block, why does it feel like it isn't? Why does consciousness experience time as a flowing river rather than a fixed landscape, if the deepest layer of physical reality shows no such flow at all? Some physicists suspect the answer lies not in the universe itself, but in the peculiar, still poorly understood relationship between consciousness and physical law, that the sensation of now, of time passing, of the future being open, is something generated by the very particular way a conscious mind processes information, moment by moment, even while moving through a universe that, underneath, doesn't move at all. If that's true, then the flow of time you feel right now reading this very sentence might be the single strangest and most mysterious phenomenon that physics has yet to explain. Stranger than black holes, stranger than quantum entanglement, stranger than the birth of the universe itself. Because everything else in physics we observe from the outside, time we experience from within. And the deeper we look into the universe, the more it begins to look back at us.